we have cosecant squared theta plus secant squared theta. And we're just told to write it in terms of sine and cosine and then simplify. So cosecant, what can you change that to? And what about secant? If you are going to add or subtract fractions, what do they have to have? So the first one has sine, so to look like the other one, it needs the cosine squared. Second one already has the cosine squared. To look like the first, it needs sine squared. So we get cosine squared theta over sine squared theta, cosine squared theta, plus sine squared theta over sine squared theta, cosine squared theta. If they have the same denominator, then we can put them together in one big fraction. Okay. What could we do here? Cosine squared plus sine squared is 1. The last step is maybe a little less obvious where to go from here, but this is all one term. It's all multiplied together. So we have seen a few times where we might break this up and say this is the same as saying 1 over sine squared theta times 1 over cosine squared theta. And what is the reciprocal of sine? Cosecant squared theta times the reciprocal of cosine is secant squared theta. So we get to that point. And then really nothing else we can do from there. All right. Number 9. Let's just kind of go through each of these and talk about what we would do. So the sine of 165 degrees. Okay, if I said exact value, that tells me I cannot just put it in my calculator and give a decimal. I have to answer with radicals. So that means I need to rewrite 165 as two angles I know added or subtracted. So what did you guys do? And that's not the only combination. I did 135 plus 30, and that also works. You could subtract angles, so lots of different options for how to get here. So what you're looking at, this is sine of A plus B. So go to your formula, sum and difference formula, sine of A plus B. So that's sine of the first, cosine of the second, plus cosine of the first, sine of the second. Does everybody see that? Okay, let's talk about the 120. What quadrant is that in? Reference angle 180 minus 120 is 60. So in quadrant 2, is sine positive or negative? Positive, and the sine of 60. Cosine of 45, so that's just quadrant 1, so just our hand trick. Cosine plus cosine of 120. So in quadrant 2, cosine is negative. Cosine of 60 is 1/2. And the sine of 45 is radical 2 over 2. So when I multiply, radical 3 times radical 2 is radical 6. 2 times 2 is 4. Plus negative 1 times radical 2 is negative radical 2 over 2 times 2 is 4. So you could write it like this. You could say radical 6 over 4 minus radical 2 over 4. Or you could make one big fraction, the whole thing over 4. Any of those are okay. You could double check yourself. Remember, we did sometimes in our calculator type in the sine of 165, which you need to be in degree mode since that's a degree. And then if you type in our final answer, we just verified that those decimals matched. So that's a quick check to make sure that you're on the right track, putting in the original and the final answer. We typically didn't like dealing with the radians so much, so what did we do on these? Those drop. So we get the tangent of 15 degrees. So then, exact value, we need two angles from our unit circle that add or subtract to 15. You could do 60 minus 45. You could do 45 minus 30. Lots of options here. 135 minus 120. Just whatever comes to mind. So this is tangent A minus B. So if you look at your formulas, tangent A minus B, that's tangent of A minus tangent of B over 1 plus tangent of A tangent of B. Okay, tangent of 60. So if you fold in your 60, tangent square root of the top over square root of the bottom. So radical 3 over radical 1 is radical 3. Minus tangent of 45. Radical 2 over radical 2. 1 over 1 plus tangent of 60. We said was radical 3 times the tangent of 45. So times 1. And so you get this answer. That is an okay answer. We know that it's better to get the radical off the bottom, but I did tell you I would let you leave it like that. That's not the answer I read off because I did mine differently. I did 45 minus 30. And when I did that, 45 minus 30, I got to the point where it looked like 1 minus radical 3 over 3 over 1 plus radical 3 over 3. That is not an okay answer. What would I have to do here? Yeah, if you take everything times 3, you get 3 minus the square root of 3 over 3 plus the square root of 3. So this is an equivalent answer. If you put these in, they give you the same decimal. So it does work. You could also multiply by the conjugate and get the radical off the bottom and get another possible answer. Like the others, if you want to check them, you can put in tangent of pi over 12, but that's in radian, so you need to be in radian mode. Put in your final answer and see if you get the same decimal both times. Is that one okay? All right, C. We have the sine of 31 degrees times the cosine of 59 degrees plus the cosine of 31 degrees, sine of 59 degrees. Okay, I said exact value, so I can't just plug this in my calculator. Look at your formulas. Sine times cosine plus cosine times sine. Does that look like any of our formulas? Okay. So my A is the 31, my B is the 59. So this is the sine 31 degrees plus 59 degrees, which is sine of 90. If I do my hand trick, Sine square root of the top over 2, so radical 4 over 2 is 1. All right, D. What do we do first here? Yeah, we don't want to leave this in radians because it's really hard to think about things that add or subtract if we're in radian mode. So we could convert this into degrees by multiplying by 180 over pi like we did on the last one. So those drop. Negative 7 times 180 divided by 12 gives us negative 105. Now you can deal with this. You just have to find two angles that add or subtract to negative 105. So you could do something like negative 45 minus 60. You could do, let's see, 130 minus 135, something like that. Or if you don't like the negative, what else could you do? Add 360 and get a positive angle to deal with. What did you guys do? Okay. So negative 105 plus 360 is what? 255. Okay, so now I need two angles that add or subtract to 255. So what did you do? 225 plus 300. You mean plus 30. Oh. Degree symbol. Okay, so this is the cosine of A plus B formula. So that's cosine of the first, cosine of the second, minus sine of the first, sine of the second. All right, let's talk about the 225. What quadrant is that? Reference angle, 225 minus 180 is 45. In quadrant 3, cosine is negative. What's the cosine of 45? Cosine of 30 is minus sine of 225. In quadrant 3, sine is negative. Sine of 45 is radical 2 over 2. And sine of 30 is 1/2. Now, I have noticed a few problems with this. People want to distribute this negative first, but start by multiplying. So if we multiply these, I get negative radical 6 over 4 minus, if I multiply these, negative radical 2 over 4. And then minus a negative makes it positive. So we get negative radical 6 over 4 plus radical 2 over 4. You could leave it like that. You might have gotten radical 2 over 4 minus radical 6 over 4. That's equivalent. You could do one big fraction. Lots of different ways that give you that are equivalent. Is that one okay? Let's look at problem 10. So we have the cosine 135 degrees minus x. So I need to simplify this. So I have cosine of something minus something. So this is the cosine of A minus B formula. So that says cosine A, cosine B, plus sine A, sine B. Let's talk about the 135. What quadrant is that from? Reference angle 180 minus 135 is 45. In quadrant 2, is cosine positive or negative? And the cosine of 45? Okay, x, so we just leave it. Sine of 135 in quadrant 2, sine is positive. Sine of 45 is radical 2 over 2 sine x. So really, there's not much more you can do. So if you left it like this, that's fine. Any questions there? Let's talk about number 12. So I know that cosine 2x is negative 3 over 4. 0 is less than x is less than 90. What does that tell me? 0 is less than x is less than 90. Okay. All right, if I want sine x, I know cosine 2x. So as soon as I see that 2x, I'm looking at my double angles. If I was trying to find sine, do we have a cosine 2x formula that involves sine? What is it? So now we can sub in. Cosine of 2x, I told you, was negative 3 over 4. So if I'm trying to solve for sine, I have to get it by itself. So first I'm going to subtract my 1. To get rid of the negative 2, we divide by negative 2 or multiply by negative 1/2. Okay, then to get rid of a square, you do a square root. Square root means plus or minus. How do I know which one I need? Good. So then I've got the square root of 7. 8, I could break into 4 and 2. So the square root of 4 is 2, radical 2. I need to get that radical off the bottom. So that gives me the square root of 14 over 2 times the square root of 4, so 2 times 2 is 4. Once I have one of these, I can get the other one a couple different ways. I could get cosine by doing the same thing, just with the formula that involves cosine. So I could do 2 cosine squared x minus 1. And I know my cosine 2x. So you just get your cosine by itself. So add your 1, divide by 2, square root plus and minus, but we're in quadrant 1, so we know it's a positive. Square root of 1 is 1 over 2 radical 2, and you get the square root of 2 over 4. So that's one way of doing it. So just a repeat of what we did the first time. The other option, once you have one of your functions with x, you could set up a triangle. You're in the first quadrant. Sine is opposite over hypotenuse. So we need Pythagorean theorem to get our missing side. We know it's a positive, so we get the square root of 2 for that side. And so then if you're finding cosine, that's adjacent over hypotenuse, and you get the radical 2 over 4 as well. So you have to use the formula to find the first one. Once you have one, you can either repeat the formula or use a triangle to get the second one. Does that make sense? We didn't ask about 13. Do I need to go over it? Okay. 14. The thing about proofs, there is not just one correct answer. So you have to make sure you're showing me everything so I know how you got to that point. We have to choose a side to box in. What did you guys box in? And so then for the right, there's a lot of different starting points. What do you guys see? What do you want to do?
I changed the sine squared of x into -1 plus cosine squared of x.
Okay. So the reason you did that is looking at your goal, you only want cosines. So we need this sine to go away. And we know sine squared x is equal to 1 minus cosine squared x. Now, you said different signs, but that's because there was a minus in front of this parenthesis. So if you distribute it, you do get the -1 and the plus cosine squared x. What could I change secant to? So part of this was just keeping my goal in mind. I knew I wanted cosines, so I left my cosine alone and everything else I wrote in terms of cosine. So on the top, if I combine like terms, cosine squared x plus cosine squared x is 2 cosine squared x plus -1, so -1. Okay, and this is all over 1 over cosine x. How do you divide fractions? That's times cosine x over 1. So if we distribute, 2 cosine squared x times cosine x is 2 cosine cubed x. Minus 1 times cosine x is cosine x. And that was what we wanted. There were different ways of getting there. Some people I know yesterday flipped and multiplied before they changed their sine squared, so they changed it later. Some people said cosine squared minus sine squared is a cosine 2x formula and used that to get there. So lots of different options. Is this one okay? Which side did you box in? Okay. So then, what did you?
Took out the 2 and then add 1 over tangent squared theta plus 1 and then -1. That's how you do it.
Okay, so you changed, I see what you did. Okay. So what she was saying is she realized that cosine squared, cosine's a reciprocal of secant. So that's the same as 1 over secant squared theta. And then, knowing your goal, we wanted tangents. So she looked at the Pythagorean identities, and one of them says secant squared is 1 plus tangent squared theta. Okay. So from here, we have 2 over 1 plus tangent squared theta. this is like a 1 over 1. If we want to add or subtract these fractions, and we know we need to because we only want one fraction at the end, we need a common denominator. So you have to take this times 1 plus tangent squared theta on top and bottom. All right. What would you do with this negative? So that's a negative 1 and a negative tangent. So then when you put them together into one fraction, 2 plus negative 1 is 1 minus tangent squared theta over 1 plus tangent squared theta. And we got there. Good. I hadn't thought of doing it that way. A lot of people yesterday when I was helping did it by working the other side, and that's an option as well. There's not just one way to do these problems. And remember, even if you start one side, if you get stuck, you can work the other one and see if you can get them to the same point. So lots of different choices. If you had worked it the other way, what would you do over here? So the denominator, the 1 plus tangent squared, is secant squared. And then, for lack of anything else to do, we could change to sines and cosines. Tangent squared would be sine squared theta over cosine squared theta. Secant squared would be 1 over cosine squared theta. How do you divide fractions? So if we distribute, 1 times cosine squared theta over 1 is cosine squared theta, minus sine squared over cosine squared times cosine squared is sine squared theta. All right. Any idea how to get from there to our goal? Your goal. We want cosines, I don't want sines. What can you replace sine squared with? And if you do that, distribute your negative, and we've got it. Cosine squared plus cosine squared is 2 cosine squared theta plus negative, so minus 1. Okay, and those aren't the only two ways of doing it. Just a couple options. So I just want to show you, just because you did it a different way doesn't mean you're wrong. Let's look at 18. Which side did you box in? Right. If you want to add or subtract fractions, what do we have to have? Alright, so the first fraction has 1 minus cosine. To look like the other, it needs 1 plus cosine on top and bottom. The second one has the 1 plus cosine, so it gets 1 minus cosine. So if I distribute sine theta times 1 sine theta plus sine theta cosine theta. Denominator, if you FOIL, you get 1 minus cosine squared theta. fraction sine theta cosine theta times 1, just sine theta cosine theta, minus sine theta cosine theta times cosine, so that's sine theta cosine squared theta, over denominator 1 minus cosine squared theta. Alright, if we want to subtract, I can change this to a plus and distribute my negative. These denominators are the same, so I can make one big fraction now. So when I put them together, we have a sine theta, cosine theta, and negative sine theta, cosine theta. Those drop out. Plus sine theta, cosine squared theta. Any ideas what to do from here? Denominator is sine squared theta. Look at our goal. We want things to be multiplied together, so we need it in factored form. What could you factor out of the top? Take out a sine. Sine divided by sine is 1. Plus the cosine squared theta. Okay, we are really close. This is all one term, so now we can cancel. So I can drop one of the sines out. And what I'm left with, this is like a 1 over sine times my 1 plus cosine squared. 1 over sine theta, that's the reciprocal of sine, which is cosecant theta times 1 plus cosine squared theta. Is that okay? Which side did you box in? Okay. So then what did you do?
Two and then parentheses 1 minus cosine squared theta.
Okay. What is 1 minus cosine squared? So that's 2 sine squared theta. Okay. Do you see how to get from here to where we need to go? What's a strategy we can use if we get stuck? Yeah, we could say, okay, plan B, I don't know what to do, so I'm going to box this in. I'm going to work the other side and see if I can get it to the same thing. So I can prove that they're equal to each other. Now one big thing I notice over here is that this sine is a 2 theta. So we need to use a double angle formula there. What can you change tangent to? And sine 2 theta is what we can do then is one of these cosines drop out. And you have sine theta times 2 sine theta, which is 2 sine squared theta. And and I got the same thing on both sides. So I'm done. Which side do you want to box in here? Big thing I noticed, we have double angles. My final answer, I don't want double angles. So that tells me the first thing I need to do is formulas to get rid of these double angles. Now cosine 2a, we have 3 different formula choices, and we can get there with any of them. But if you think about your goal, you want both tangent and cotangent. That means we need both sines and cosines. So I would pick the formula involving both of those. So that's cosine squared A minus sine squared A. Over sine 2A, there's only one formula choice. 2 sine A cosine A. What happens there? And now we have to really use the same strategy here and on problem 21. You have 2 terms on top and only 1 on the bottom. So you can break it up. You can put each of these terms over the entire denominator. So in the first one, I can drop a cosine out. In the second one, I can get rid of a sine. So in the first one, I have cosine over sine, which is cotangent. Second one, I have sine over cosine, which is tangent. Remember, those quotient and reciprocal identities are not given, so you have to know those. So let's say I told you to find tangent of 2 theta if cosine theta is 5/13 and 270 is less than theta is less than 360. So, tangent to theta. We have a formula for that. What is it? So in order to solve this, I need to know what tangent of theta is. How am I going to find my tangent of regular theta? We could do a triangle together. If you were between 270 and 360, that's quadrant 4. Cosine is adjacent over hypotenuse. 5 squared plus b squared equals 13 squared. Would b be a positive or a negative? Negative, because you're going down, so this side is negative 12. So then, if we think SOHCAHTOA, tangent is opposite over adjacent, so that's negative 12 over 5. So we could work this out. You could also use a calculator at this point if you get stuck. 2 times negative 12 over 5, that's negative 24 over 5. 1 minus negative 12 over 5 squared would be 144 over 25. Why don't you guys go ahead and evaluate this? Tell me what you get. Is it 120 over 119? So we just had to use a formula. What else? Anything specific that we've had trouble with?
Can we do another one like this one, please?
So another double angle. Okay. So what if I said this one, we have a few more options because I asked for cosine 2 theta. And don't we have 3 different formulas for that? So we could use any of the 3 formulas. Which one do you want to use? If you use this one, you don't have to set up a triangle at all because I gave you sine is negative 5 over 7. And you could use a calculator if you needed to. Get negative 1 over 49. If you had used either of the other 2 formulas, they both involved a cosine, so you would have to set up a triangle in order to find your cosine theta. But by using this one, we saved ourselves that step. So basically with these 2 theta formulas, you have to use your formula, and if it asks for a trig function that you don't know, so like here, this one called for a tangent and I didn't know it, you have to set up a triangle. You know, if I had chose to do this one by doing the 2 cosine squared minus 1, I'd have to do a triangle in order to get cosine. So if you